So we would multiply like a 3-digit number by a 2-digit number. So let's look at the example 24 by 365. The area model really helps us really get into these types of problems right here using pretty much the same strategy we did with a two-digit by a 2-digit. Again, I could do it by the area model, but I'm just going to model it just using the algorithm, the shortcut. So I'm going to put the 365 on top. The one with the most digits I usually put on top, it just makes it easier. Times then the 24, we'll put it on the bottom. Again, basically what we're doing is we have to do like actually 6 multiplications. We have to find the 4 times the 5, the 4 times the 6. Remember, this 2 is actually a 20. So that's going to be a 20 times those. But remember, we just put that trailing 0 down. So it becomes then just 2 times 5, 2 times 6, and 2 times 3. So using the distributive property, we're going to multiply the 4 times the 5. That's going to give us 20. But remember, we just bring down the 0. We carry the 2. And then we have 4 times 6. Remember, 6 times 4 is the 24. It's the rhymer. And then plus the 2 makes the 26. So we bring down the 6 and carry the 2. And then 4 times 3 is 4 3s or 3 4s. So that's going to be 12. And then plus 2 more would be 14. So it's going to be 1460 would be the first one. And then when we do this 2, remember it's really a 20. So we'll go ahead and put down its trailing 0. And now just focus on the 2. 2 times the 5 is the 10. Bring down just the 0. Carry the 1. So I'm mark that 2 out. 2 times 6 would be 12. Plus the 1 is 13. Again, just bring down the 3. Carry the 1 over to the next spot. 2 times 3 is 6. Plus the 1 makes 7. So these are our partial products. It would have been actually 6 different areas combined together. But it just makes it easier to do it this way. So now we just add the 2 partial products. 0 plus 0 is 0. 6 plus 0 is 6. 4 plus 3 is 7. And 1 plus 7 is 8. And then based on our place values, that's 8,760. That would be our result. So if we look at 57 times 298, again, the one with the most digit goes on top. So the 298 times the 57. The catch of all this is learning how to lay a problem out on paper, giving yourself plenty of room. Really, I need room above it, and I need a lot of room below it. So just be careful when you lay it out that you make enough room. 8 times 7, again, if we use our 8s or our 7 tricks, we would get the 56. We carry that 5 over. 7 times 9 or 9 times 7, 63 plus the 5, 68. Carry the 6. 7 times 2 is the 14 plus the 6 would make then 20. So that comes down. We're at the end of the problem, no more carrying. I can go ahead and mark those out. We're done with those. Now when I start with this 5, remember that's actually a 50, so the trailing 0 comes in as a placeholder. 5 times 8 is 40. So I bring down the 0. Carry my 4. 5 times 9 is 45. Plus the 4 makes 49. Carry the 4. 5 times 2 is 10. Plus the 4 makes 10 at 14. So we add together our 2 partial products. Since this was found by doing multiplication, this was found by doing multiplication. So now we add 6 plus 0, which is 6. 8 plus 0 would be then 8. 0 plus 9 is just 9. Got some pretty easy numbers here. And 2 plus 4 would be then 2 plus 4 would be 6. and then bring down the 1. Now it's really where the comma is important. Once you get past the thousands place, the 10,000s and on up, we need to really put the comma in there to really see the problem. So 16,986 would be the answer. If I do a 3-digit by a 3-digit just for the fun of it, if I have, say, 3, 6, 5 times, then say 1, 2, 3, just having some fun with 1. So when we do this, we're actually going to have like 9 different multiplications to do. So this is where knowing those math facts makes this actually pretty easy to do. 3 times 5 is 15, so we carry the 1. 3 times 6 is the 18, plus the 1 is the 19. 19, carry the 1. 3 times 3 is 9, plus 1 makes then the 10. So I can kind of mark those out, say we're done with those. Now remember, this 2 is actually a 20, so I put a 0 as a placeholder. Now I can just focus on the 2. 2 times 5 is 10. You carry the 1. 2 times 6 is 12, plus the 1 makes 13. Carry the 1. 2 times 3 is 6, plus the 1 makes then 7. Well, now I come to the 1. Notice the 1 is actually 100, so I actually have to put 2 trailing zeros in there for the 100, 2 placeholders. So then I can just go 1 times 5 is 5. 1 times 6 is 6. And 1 times 3 is 3. So actually I have 3 partial products that I have to add together. So it just becomes a longer and longer problem, but the process is basically the same. So 5 plus 0 is just 5. 9 plus 0 is 9. 0 plus 3 plus 5 is just 8. 1 plus 7 is 8. 8 plus 6 is 14. Carry the 1. 1 plus 3 is then 4. So then we have to put our comma in to help us read it. So 1s, 10s, 100s. It breaks apart the thousands period. So the thousands period, you have 44,895. That would be your solution. So that's where we're going to go, is we're going to try to do some multiplication like that. And all this really kind of is derived from the area model. If you like the area model, you can stay with it. You don't have to do it this way. This is just a little bit shorter than the area model.